Hello, everyone. My name is Hietpas, and I am here with Hein to discuss conventional machining with cutting fluids versus dry, high-speed machining. Now, what is conventional machining? As many of you might know, conventional machining is the metalworking process of removing some material to create a desired geometry. This process utilizes a cutting fluid, which is usually some sort of oil or synthetic-based liquid. This is used to ensure that the part is properly cooled during the machining process. And during this process, there's also a lot of chip production. This fluid also helps wipe that away. Now, there's another type of machining that we're going to be talking about, dry high-speed machining. As the name entails, this type of machining uses no liquid whatsoever. This has a couple ramifications. For one, pressurized air is almost always needed in these type of processes to help mitigate some of the risks. Furthermore, there is increased heat and there's no chip flushing because there's no liquid to help cool and take away those chips. Because of this, specialized tools are needed, and there's a couple more limitations to this process. Some of those specialized tools include chip breaker geometries to help reduce those edge buildup, and so that despite it not being able to be washed away, not as much forms, or the stuff that does form gets a little bit brushed away during the process. Furthermore, there are some harder material tool pieces needed, and or coating used to increase tool life. One of these is ceramics, due to the fact that they do not conduct heat very well. Finally, another important note is that they run at a higher horsepower to maintain the same production speed, so they can be a little more energy intensive at times.
All in all, the process of dry machining has many pros associated with it. The first and most obvious is that dry machining eliminates all costs associated with cutting fluid. These include the direct cost of buying the fluid itself, but also many indirect costs associated with cutting fluid. Some examples of this are the processing required to drain out cutting fluid after it has been used, as well as the cost of drying and cleaning chips, which can't be recycled with cutting fluid residue still on them. The process of dry machining also reduces thermal shock in tooling. Thermal shock is common when using cutting fluid due to the rapid heating and then immediate cooling when a tool is being used to cut and then not cut. The reduction of thermal shock can greatly increase tool life under certain conditions, particularly with rigid tools such as ceramics. Another pro of dry machining is the positive environmental impact it has due to not being reliant on cutting fluids. Cutting fluids are oil-based and heavily regulated by many countries, particularly those in Europe in high manufacturing environments. It has also been shown in a study conducted by the U.S. National Library of Medicine that long-term exposure to cutting fluid has many adverse health effects. However, there are also many cons associated with dry machining. Most of these cons come in the form of limitations for what you can and can't do with the process of dry machining. The first limitation is that it is not possible to conduct many machining operations due to the heat-generated zones which are not cooled in the process of dry machining. One example of this is deep drilling, where the tool must be exposed to the heat-affected area for long periods of time when it is actively drilling. As well, it is not possible or extremely difficult to use dry machining with many common materials. Typically, dry machining can be effective when used with cast irons or high-strength steels, but when used with materials more flimsy than those, such as aluminum, the affected areas contain much more excess heat than with cutting fluid, which can cause the parts to deform after they have been cut and can cause them to become out of specifications. As well, harder materials, such as nickel alloys and titanium, create too much heat during dry machining and makes them effectively impossible to work with. The process of dry machining also creates large amounts of metallic dust, which must be filtered, or they can cause severe adverse health effects to operators in the machining environment. As well, dry machining requires cutting tools to either be of a harder material, such as ceramics or concrete, or have to be coated, which incurs extra cost. As well, if not done properly, dry machining can lead to inconsistencies in chip formation, which will cause the chips to stay within the machine bed and cause the dry machining process to cut them twice. This does not happen when using cutting fluid because all of the chips are blasted away by the fluid. This action of cutting twice can greatly reduce tool life in these situations if not properly accounted for.
Cost analysis. Cost analysis. There are many pros and cons of both conventional machining and dry high-speed machining. Some of the pros of conventional machining are that there's relatively good finishes, which means they don't need to spend a lot of money in extra tooling. Furthermore, they can use any tool type, reducing any costs of needing specialized tools. There are some cons, however. The cutting fluid used is very expensive. Although the sources are varied, it ranges from roughly 15 to 20% of the total manufacturing cost just to get rid of that excess cutting fluid. Furthermore, this price may increase as there are increasing environmental regulations every year that makes it even more expensive to deal with this cutting fluid. On the dry high-speed machining side, there are also some pros and cons. On the pro side, it's a lot easier to collect and recycle the chips as they don't get washed away. And they don't need to deal with any of those environmental regulations or the cost of buying the fluid as no fluid is used at all. Some of the cons are that in certain situations it can massively increase tool wear, leading to tools breaking nearly twice as fast. Furthermore, sometimes high ventilation is required due to the creation of dangerous metallic dust. Overall, it is very situation specific which one is more cost effective. Dry high-speed machining is more limited in its usage, and as such can be very cost effective, but oftentimes for certain materials is too pricey. Manufacturing readiness level, or MRL. The manufacturing readiness level roughly measures how well a process can exist in manufacturing. For high-speed dry cutting, we have determined that it would be about an MRL 9. This is because the technology is sufficient and there is a well-established design that mitigates any health risks. Furthermore, the needed materials are available and the cost analysis is roughly known, although this cost does vary from each situation to situation. Furthermore, low production rate has been demonstrated in a variety of locations. However, it is not quite an MRL 10 because it doesn't quite meet all the engineering performance, quality, and reliability requirements to be MRL 10. This can be seen in the quote, which states that most machining applications do not yield satisfactory geometrical accuracies, surface properties, tool life, chips evacuation, and production rates without that cutting fluid. Because of this, we are confident to say that it has a manufacturing readiness level of 9. These were our references. As can be seen, all of our references came from very reputable sources. Throughout this presentation, we used 6 different journals. These included the International Journal of Heat and Mass Transfer, as well as the Journal of the Brazilian Society of Mechanical Sciences. Furthermore, a lot of our sources had independent studies performed during them, such as the study on health issues due to the exposure of cutting fluid and a study on surface quality of high-speed machining. Overall, we did our best to avoid any sort of biased sources and only used the most reputable sources we could find, or those who did our own independent studies.
For processes that we are already pursuing, such as milling and turning of high-strength steels and cast irons, it is our belief that dry machining can provide a very adequate and beneficial substitution for traditional cutting fluid machining.